Hey guys, this is the problems of the day for evaluating for trigonometric functions on the coordinate plane. So let's start with this first question. Given that P at -3, 0 corresponds to a point on a circle that corresponds to the central angle, find the values of all 6 trigonometric functions at that angle. So what we know here is when we're given this point, x is -3 and y is 0. But in order to evaluate for all of these trigonometric functions, we need to know what r is, the radius. Because remember that cosine is x over r, sine is y over r, tangent is y over x, secant, which is the reciprocal of cosine, would be r over x, cosecant is the reciprocal of sine, so r over y, and cotangent is the reciprocal of tangent, so x over y. So like I said, we need to know what the value of r is. Now remember that r is equal to the square root of x squared plus y squared. So I'm going to plug in my x and my y to solve for r. So r equals the square root of -3 squared plus 0 squared. -3 squared is 9 plus 0, so 9. So r is going to equal to the square root of 9, which is 3. Remember that anytime we square root, the answer is always plus or minus. But the radius of a circle is always going to be a positive number. So we just take the positive value for r. So now I'm going to make my little list here of what x, y, and r are equal to so that I can input that for these trigonometric functions. X is -3, y is 0, and r is 3. So the cosine of theta is x divided by r. So that would be -3 over 3, which gives me the answer of -1. Sine of theta is y over r. So y is 0, r is 3, and 0 divided by anything is 0. Tangent is y over x. So y is 0, and x is -3, and again, 0 divided by anything is 0. Now secant is the reciprocal of cosine. So we can look at either the fraction or the number, it's up to you, but basically it's the reciprocal of -3 over 3, which would give you 3 over -3, which when you divide would still give you the value of -1. Now cosecant is r over y. So if I input r, I get 3, and y, which is 0. But here's the issue. We have 0 in the denominator. And if you ever have 0 in the denominator, that just means that that value is undefined. There is no cosecant of that angle because we end up with 0 in the denominator. And we're going to see the same thing now for cotangent. Cotangent is x over y. So -3 over 0. But again, we have 0 in the denominator, so this would be an undefined value. Now let's look at this next question. Given that the cosecant of theta is equal to 2 square root of 2, and secant of theta is the square root of, is less than 0, use trigonometric identities to find the values of cosine theta and cotangent theta. So I have here like a little hint for you. First, you will need to determine the quadrant the angle is located. And we do this so that we know what signs all of our values will be. Then we will find the values of x, y, and r. So let's first figure out that quadrant. We are given cosecant is a positive 2 square root of 2. Now cosecant is the reciprocal of sine. So if cosecant is positive, sine is also positive. So that means that I could eliminate quadrant 3 and quadrant 4, since sine is negative in these two quadrants. Now here it says secant of theta is less than 0. So if secant is less than 0, that means its reciprocal, cosine, is also going to be less than 0. So that means that I could eliminate quadrant 1 since cosine is positive in quadrant 1. This means that we are located in quadrant 2. Now the reason that I figure out why that we're in quadrant 2 is to make sure that we know what signs x and y will be. In quadrant 2, x is negative and y is positive. So when I look at my values, I will know to make x negative and y positive. So now that we've figured this out, we're going to look at that cosecant of theta value and see what variables we can determine from that. Cosecant of theta, as we noticed in the previous example, is r over y. Now what we have here is not a fraction, but any whole number, so 2 square root of 2, will always be over 1. So what this means is that r is equal to 2 square root of 2 and y is equal to 1. So now what I need to do is I need to figure out the value of x, because that's what I need in order to get cosine and cotangent. So remember, we're using this equation. R is equal to the square root of x squared plus y squared. We know r this time, so we make 2 square root of 2 equal to the square root of x squared, which is what I'm trying to solve for, plus y squared, which is 1. So now what we do now is we need to cancel out this square root. So I'm going to square this side to get rid of the square root, meaning I would have to square this side as well. So this cancels out. And then here I have 2 square root of 2 squared. So remember that we have to take that exponent and apply it to both the number outside and the number inside. So 2 squared is 4. And the square root of 2 squared would just cancel out the square root, so 2. And that's going to equal to x squared plus 1 squared, which is 1. 4 times 2 is 8, which equals to x squared plus 1. Subtract the 1, we get that x squared is equal to 7, and then square root both sides. Now remember here, when you square root a number, it's always plus or minus. And that's why I wrote down here, x is negative in quadrant 2. That means that x will be the negative square root of 7. So now I have all of my values. So I'm just going to create a little table here. So x is equal to negative square root of 7, y is equal to 1, and r is equal to 2 square root of 2. Cosine is x over r, so negative square root of 7 over 2 square root of 2. But what I have here is a radical in the denominator, which remember we can't have. So we're going to go ahead and rationalize this. I'll do that down here. So we have negative square root of 7 over 2 square root of 2. To rationalize, I'm going to multiply by the radical that we have in the denominator, so the square root of 2. And that's going to equal to negative square root of 14, since here we can multiply those radicals together, over, we have this 2, and then here those square roots would cancel, so 2. And now what we get is negative square root of 14 over 2 times 2, which is 4. So this would be my cosine value. Now we're going to do the cotangent. Cotangent is x over y. So negative square root of 7 over the y, which is 1. Which if it's over 1, we don't need to really write that. So it would just be negative square root of 7. And this would be the cotangent value. And that's it for the problem of the day.